Welcome back, everyone, to Supercomputing live stream from theCUBE. I'm John Furrier, host with Jackie McGuire from theCUBE Research. So we're breaking down all the AI infrastructure innovations from HPC now, full-on AI cloud. All the actions here. This is day 2 of 3 days of coverage. Vik is here. He's the Managing Director and President of EMEA, Senior Vice President of Technology and AI at Supermicro, a company that's been instrumental in providing a lot of the compute and the gear over the many, many decades, now the center of the AI factory conversation. Vik, thank you for coming on theCUBE to wrap up day 2.
Thank you for having me here.
I have to ask you, so you're SVP of Technology and AI at Supermicro. I know you guys have been doing a ton of work, storage, networking, and obviously the compute side, legendary. I think my startup 16, when I started this company, I actually bought a Supermicro box and had to host it. And then the cloud came, and then they're still buying. So you're at the center of the AI revolution, but the game is still the same.
Yeah. Game is still the same, getting better, because the nerd nature of the humans is not going anywhere. So people still like to build and experiment with things. So we still continue to support that. That's a huge customer base for Supermicro. But at the same time, you're right. A lot of things are going into cloud, but there's also repatriation from cloud is also happening because of the cost and other reasons. Cost is, of course, it's how it started, but cloud is increasing. I mean, the total pie is exploding, so it's not that, don't think that, it's going away. But people are repatriating because of the cost, because of data sovereignty reasons, because they want to make sure that they are able to have the flexibility to choose whichever the platform or technology that they want to adopt.
The systems game is back, and if you look at all the AI factory conversations around this AI infrastructure, it's essentially a system architecture. It has all the elements, and the density is increasing. This is a core competency of Supermicro. How are you guys looking at that right now in terms of what's state of the art for you guys as enterprises? Again, the data and the compute, that's the name of the game. The on-prem, those are the crown jewels, seeing a lot of build out there. Of course, the neo clouds are emerging fast, and then you got the neo clouds and the enterprise, 2 hot sectors of build out right now.
See, the good thing is that even when Supermicro was 30 years ago, when we were making subsystems, the largest exciting part for Supermicro in larger deployments is high performance compute. So because of that, we are used to being part of the larger deployments with performance being the key and density being a part of it. Because in order to reduce the total cost of the networking overhead and everything, nodes need to be next to each other. So that's how the denser platforms. In fact, we worked with Intel, and we were the first to introduce the twin platform, which pretty much is a de facto standard now in a compute world, right? That's number one. Second is, as we look into AI deployments, one of the things that we kind of literally leveraged on that is because we do develop everything in-house, that helped us to adapt to the changes very quickly and be able to bring the platforms that are more relevant for different verticals, whether it's enterprise or cloud or even HPC side of it. Now, when you go into the AI factories, the way I see it is we are the factory that is enabling the AI factories, right? Because you need to bring the infrastructure together in certain way very quickly and more efficiently and be able to roll in these systems along with the software with NVIDIA and whatnot, be able to get to the customers.
We are going to do a big thing on Inside the AI Factory content series, because there's a lot of interest around what's in the factory, the memory, the storage. You guys have we actually did a showcase with this year with Supermicro, and people might not know this, but you guys have a huge ecosystem of partners.
Absolutely.
And open systems has been a great wave that you guys have rode as a company, but now you got open ecosystems, co-design, you have partners that are critical to that. So talk about the open and the partner network that you guys have, because it's pretty huge.
It's really a fundamental shift in business, right? And the kind of collaboration over competition.
It's all a collaborative effort. It takes a village to get things done. So if you take a look at standards point of view, initially we started with all the 19-inch standard rack designs and everything, which is open standards, and we started adopting the best practices in the industry. For example, we started incorporating open BMC and open BIOS, which actually gives the flexibility for people to modify to make it work for them. And then we went with the OCP NIC, open compute, ORV3 based GPU accelerator modules. And when we started incorporating that, we also looked at in the rack level as people are deploying it at scale, to your point, when the density increases. Now, take an example of NVIDIA GB300 NVL72, the stuff that is, a lot of people are interested in taking a look at. This is nothing but an ORV3 rack. So we started adopting that as well. So twofold. Number one, whether it is the traditional, conventional standards that people are used to, the 19-inch racks with, IPMI as a management interface and Intel or AMD as the standards and whatever, that is one thing. But we are also adopting quite a bit with OCP community to incorporate those changes into the platform design. So it's, again, about giving a choice to customers to choose from. That is on the hardware front. But when you talk about the software, just to give you some idea, on an accelerated compute, like a GPU platforms, the most expensive thing in the cluster is GPUs. We want to keep them busy to the extent possible, which basically means the network with the lowest latency, highest throughput, and two, the storage that need to be highly performant. So we come up with many of these high-performance storage arrays, but storage array is hardware. So we have at least 15 different ISVs that we work with just on the storage, just to give you some idea, like VAST, Veka, DDN, Cumulo, you can kind of OS Nexus.
Who's who?
Yeah.
This is exactly. So whoever you think is actually focusing on high performance, high resiliency, we are working with them to do that. And as for the networking piece of it is concerned, we do work very closely. And then let's say, for example, if someone wants to go with an Arista, Juniper, Cisco switches, fantastic. Otherwise, we also have Supermicro switches that's based on the Broadcom silicon with, think of like Sonic Enterprise OS.
Like Tomahawk?
Standards. To the extent possible, if it is open standards or industry standards, we want to incorporate into our designs.
How are you bringing all those subsystems closer together with density? Because you guys have been living the storage, compute, networking game for generations, like I said, but now it's large-scale clusters. In some cases, the data center itself is a supercomputer. So you have to kind of bring together all those three.
I mean, it's a very complex equation. I'm actually super excited to be part of it. Just to give you some idea, if you build, like take an example of a GB300, I'm giving the reference again because it's the highest performing GPU cluster today. A single rack, goes in excess of $4 million. And if someone were to take it and deploy in a data center, if the liquid cooling is not ready, if the power delivery is not ready, if the cooling is not there, so then that entire infrastructure is sitting there unused. This is something that we are looking to address. And just because the way we are addressing the solution by building block approach, yes, we took it to the next level and say, think of data center as a building block. In your parlance, it's like a massive supercomputer. And everything in that need to work, and the telemetry has to work in order for people to be able to deploy and use it. So what we are doing is, just to give you some idea, a system sitting in a rack, and a liquid cooling distribution unit, and the distributor along with it, the plumbing to whatever the facility water, and the water towers outside, and bringing all of them into a single pane of glass to manage it, again based on open standards to the possible extent, and working with different ecosystem partners and validating their solutions in this also. For example, I could be using CoolIT or Motivare or someone else's racks or rear door heat exchangers and whatnot, but we have our own offerings also validated on that. So at every stage, we want to have different building blocks. So when you put it all together, it's going to work seamlessly. That's the direction.
I love this for technology because I think for the later part of the 90s, 2000s, even the 2010s, we had this whole walled garden economy, right, where venture capital and private equity really poured gas on the flame of intellectual property, don't work with other people, nothing's interoperable. And it's really cool to me that as millennials start to come into buying power in the enterprise, and they'll have more money than anybody else by the end of this decade, they have a really strong preference for collaboration over competition. And so it's really nice, especially as an end user, to see the walls come down, to see this interoperability, to see the embrace of open standards, because I want to be able to choose best of breed. Or if I have an older data center, to your point, and I want to be able to start bringing in new components, like I may not be able to bring in a full factory. I may need to do it piece by piece. And so I think this is one of the best things that can happen in technology, is that we have to grow so fast that companies don't have a choice but to interoperate, because I think it kept a lot of innovation from happening through at least the 2010s.
Right? I mean, look at it. We are at Supercompute, right? I mean, this is bunch of engineers and developers, whether it's hardware, software, and in terms of AI-centric applications. People are talking about all these agentic AI, workloads. So when all of these people are working together and be able to innovate quicker, that is what we want.
Yeah.
And that only happens when there are some standards. The standards are make it easily available for people to go develop on. I think it's going to be a win-win situation for the industry and everyone.
Standards really make the builders innovative and also creative. And that's one of the things coming out of the AI side too, the creativity. You mentioned GPU utilization. The theme that we've been hearing throughout the week so far is this GPU starvation concept, where, hey, this is the most expensive resource. However, there's memory and you got storage. So let's rethink that system architecture, because we want to make those GPUs utilized. And we're hearing people are, some of the big neo clouds are clocking 95% plus utilization. Enterprises and others are around 65. So that means there's a lot of idle GPU around. So the engineers are going, hey, I could do things like offload.
I mean, there's so many companies are coming up and working on this, solving this problem, because primarily it's all started with training workloads, so which were beating up the systems as much possible, as long as the network and storage is being there to support them. But as the inferencing workloads are coming in, it's going to be spotty, right? I mean, it could be heavily workloaded and not. And the other thing is heterogeneity, right? So you talk about AMD, NVIDIA, Intel, and others who are coming on the inferencing applications. When people start adopting all this, the companies are popping up to kind of abstract that layer and be able to guide that application to the appropriate accelerator or GPU to get the works done. Again, all of it is about how we keep the GPUs busy and how we improve the productivity and how we bring the total cost of ownership
load
down.
balancing on steroids.
It's funny because GPU came about as graphics processing unit. We know the history. It's actually just compute, but it's just NVIDIA gets the name GPU, and it's got the math spine and the matrix and all that
Because
stuff.
it started off that, they led the industry and they continue to do so.
It's a high-performing AI processor, but to your point, as inference becomes nuanced or situational or contextual, whether it's at the edge or a workflow or an AI native app, you can use other compute and architect things around it. Maybe the workload is going to use a small language model. You mentioned training. Yeah, the big guys are doing the training, but you can do reinforced learning on other models and then do inference on the fly.
Right.
The
That's
best
the
thing about agentic AI is that we're not trying to use an LLM to solve all of the world's problems, because they're so inefficient.
Yeah, but you can configure
I came from the chip development background, and then I used to spend so much time in validation, right? And I was talking to this company called Chip Agents, and looking at the way that they are doing and using agents in this one, it reduces the time by 60-70%, and it actually does a phenomenal job. I mean, I'm just giving one example, right? Incorporating these things and amount of innovation that's happening, it requires a huge amount of compute power, which basically translates to how we make the deployment and easy, and how we run it more efficiently, and how we innovate, right?
Yeah, I think DeepSeek was really instructive. It was 2 years ago, 23 here around November, it kind of came out. Full year of 2024, speculation, what does it mean? But it taught us that you can actually configure other chips to kind of get the performance levels with open source software. And it's not a one-trick pony, just GPU. You can actually have other mechanisms. So you're in this business of builders, so builders now can configure.
Right, and I see that the innovation is happening. We have, several companies that are working with us in the sense taking our hardware and popping up their accelerators. For example, Furrier AI is one of them. Let's say Rebellions is other company, and even Qualcomm, and so many of them, whoever is making the accelerators, they need systems to plug in, which actually provides them the best value and best performance, and they can innovate on it. So from our point of view, I see is that NVIDIA, while we lead with it, based on the customer preferences and requirements, there are so many other options that are coming up, and we are very much in the game to help as many ecosystem partners.
So I have to ask you, so we've been talking about HPC and AI kind of coming together, kind of one thing now, even though HPC has a storied history here at this show. What's the difference between HPC workloads and AI workloads as they blend together? What's your view on that?
So few different ways to slice and dice, right? First of all, in terms of the infrastructure point of view, AI clusters pretty much took all the best practices from HPC and took it to the next level because of the need, number one, and the second thing is there's no other choice in order to get the right performance and be able to converge the models better. But then when you take a look at today, much of the workloads for AI are about training the models, which is like probably like FP32 or FP16. And then the inferencing is going towards even smaller, like an FP8 and FP4. Whereas much of the scientific community is still dealing with floating point 64-bit operations. So you take a look at that HPC point of view, there's still a lot of focus. In fact, like when somebody asks to our booth, then they say like, we have all these Intel and AMD latest generation CPUs, but we also have the GB200s, which are fantastic for HPC applications. But when you start looking at the newer ones, which are primarily focusing on AI, so the scientific load kind of changes sideways. So there's a little bit of digression, but at the same time, HPC historically was designed to scale across as many nodes, while inferencing versus the AI, majority of them are now trying to pack as much punch in a single. So both scale up and scale out is becoming very important for that. HPC historically is more scale out than scale up.
So AI's got a little bit of both. I have to ask you, because you're involved in the EMEA side of the business, Europe, Middle East, and Africa, as well as the SVP of Technology and AI. Sovereign clouds are coming, AI clouds, you already see neo clouds. Talk about the sovereignty piece, because sovereign AI is being talked a lot about. There's a little bit of different versions of that, where you sit in the room. What is sovereign AI? Because if these AI factories continue, you're gonna have the core factories, which we're seeing now built out, and you're gonna have edge factories, gonna be hyper-converged at the edge, and you're gonna have micro factories, distributed computing. So if that happens, we're going to see a lot of clouds. Sovereign has to play into that.
Right. The way I see it is that the entire AI that we are planning to use is to make the user experience better. Right. It could be language, it could be health, it could be shopping experience, it could be any of those things. And then when you are dealing with people's data, and let's say take it to next level and put a country level data, that becomes a lot more critical than ever before, because earlier the data was there, people were not doing much with it. Yeah. Now people are very sensitive about what data being used for. Yeah. It could be for national security also, for all matters, right? So data sovereignty becoming important. And then in order to provide services that are localized for your area, you need to have models that are optimized for what you are doing. So that's the reason certain large language models are adopted and they're retrained with the local data, with the guardrails, and it stays local. That way no one else has access to that. So this is actually not a fad. This is absolutely needed, and it's actually increasing day by day.
Vik, you mentioned the countries. One of the things that's coming out, I'm learning from this show this week, is the national angle actually is a new metric that's superseding, or in some cases at parity with, classic nerd metrics. Like how do we optimize efficiency, all the things we talk about. But now you have this other qualitative, has nothing to do with money, it does at the end of the day, but decisions are being made at large scale over national clouds. Even the US, we see NVIDIA doing what they're doing, and others.
Europe is also
Europe is huge. So
like the Euronet, I don't know if you're familiar with this. So Europe is really kind of going all in on open source, and they have this huge project called the Euronet, where it's basically focused on open source technologies, making, democratizing the technologies that are powering AI and cloud computing. And
it is certainly happening, but the difficult part is this, right? I think as you are alluding to, the cost of infrastructure is so expensive, and the amount of power that is needed, and the data centers that need to go along with it, the whole thing need to come together, and the investments need to happen from the governments. And in Europe, I think some countries are actually going forward with those investments, and many countries are not. Yeah. Because if you have fixed amount of budget, what do you prioritize at a given point of time? And second is, no matter whether you like open source or not, you will be using it, but the priority will be over getting the work done quicker, then comes the rest of it. For example, one of our key customers, I was talking to them about infrastructure, And I was talking to him about efficiencies and how to build these liquid cooling systems. That way they can do better. And the single comment he had was like, I'm sold on physics, but can you give me the air cooled versus liquid cooled? Can you give me the liquid cooled systems one day prior to air cooled? And I said, no. Then my answer is, I want the air cooled to go with it. And when you're ready to provide liquid cooling at the same time as air, I would like to go with it.
Supply chain is going to drive
It's the
so
business
much.
that is driving it.
Yeah, in the ability, we've been able to deliver a lot of capacity fairly quickly, but I keep saying that I think our ability to physically continue to deliver capacity at that scale is going to slow down. You can only build so many data centers so fast, right? So I really do think supply chain, to your point, like people will take things faster rather than better quality right now. So
You may believe or not, but I'll tell you, in the last 2.5 days, I have at least 10 meetings with the data center providers. So the people basically have power, they're trying to build a data center, or people have power and data center, they're trying to refine the infrastructure to kind of bring the equipment home. They are trying to find out who do they need to work with. And the customers who basically have a dire need, they are trying to figure out who are the data centers that they need to work with.
Yeah.
And these two guys are trying to figure out who are the ISVs that they need to work with and who are the end users that they need to deal with. The equation is getting quite complex. And to your point, the deployment needs are increasing, tremendously. So whatever that we can do to speed up.
It's the supply chain on one hand, but also it's the stakeholder evolution, because now you have different stakeholders aligning around resources like energy. I got my real estate, but the grid's not good here, but I got space. So now new dimensional kind of physical.
Yeah, perfectly stated. That's the real. 5 years ago, if I were to go to a data center and say hey, what exactly are you doing? They say why are you asking me? Yeah. Versus now, if I don't ask, they won't talk to me because they know I don't know what I'm talking about, right? The idea is, no, seriously, because if someone says I am deploying a 1,000 node cluster, the first question I'm going to ask is where? Do you have the data center ready? Show me the data center contract.
Yeah.
And who is the end user that you are going to support and where the money is coming from and how are you planning to manage it? This is
and the biggest
look
thing,
at everything.
The biggest thing I keep hammering on too is even if you have the real estate, you need the people. You need people who can pour that foundation. You need people who can pull those cables. You need people who can service those generators and chillers. And that's one of the biggest impediments, I think, is if you're trying to build a data center in Kentucky.
That's all I got.
Yeah.
We've loved it for years.
Yeah.
Nick, it's great to have you on. I'm super glad you stopped by to wrap up our day 2.
Thank you.
You're awesome, great insights. Appreciate your knowledge, sharing with our community. And I'll give you the final word. Put a plug in for Supermicro. What are you excited about? What's the coolest thing you're working on? Don't say cooling. Okay.
No, cooling is hot stuff, not cool stuff.
That's good. We'll use that one. Put a plug in for what you're working on.
But in all seriousness, what we are trying to do is the amount of time it's actually right now for refresh cycles has gone from 3 years to 2 years, now less than 1 year, which basically means we need to innovate quicker and we need to bring the solutions quicker to market. If we are not able to do that, and if you're not able to enable the customers better, by the time they buy the hardware, it's already end of life. So what we are trying to do is to kind of showcase the products and technology here. And if anyone is around, then just come by to Supermicro booth to see them.
Yeah, well, super psyched to have you, and we'll certainly invite you to our Open Storage Summit in 2026 with Supermicro, which we're going to do again this year. Appreciate your time. And again, it's so much going on. Again, the world is changing. The stakeholders are changing. The technology is changing, but it's enabling an accelerated value proposition that's going to fuel open source, open silicon, and again, change the world as we know it. theCUBE's doing its part here. Day 2 wrap up here at Supercomputing. I'm John Furrier, Vik McGuire. Thanks for watching.